So we're back in algebra again today, the start of week 5. So our normal 8-week term is about halfway over. We've got a little bit more time than that this term, a few extra days. So we were not pushed through this section on graphing and equation writing the way that I have in some terms in the past. So today we're going to shift gears and start looking at how we can write equations in slope-intercept form. Hopefully by now everybody remembers slope-intercept is y equals mx plus b, because the two things that are important for writing equations, anybody remember what those two are? You think about it, I'm going to turn the light off. Now, as long as we're talking about
Rise or run.
That's one of the things. Yes. She said rise over run. That is absolutely correct, otherwise known as M in the equation.
Yes, the slope.
Yep, slope.
M is the slope.
And what else do we need to write an equation in slope-intercept form? Nah, we're going to use those though. We're going to use coordinates to help us. Those are coordinates. That would be how we might find slope. We'll have to do that on some examples here too.
We have to know the points.
What specifically? What point? Can you narrow that down?
2 points. Like y minus y 1.
That's
No.
we would do that if we're looking for slope.
Yes.
So you got half of it. You guys are on half of it. You're circling around the other half. The Y-intercept. Thank you. Yes, we need B. We need B. So when Ozma, when you said the point, I thought maybe you were referring to that, because in slope-intercept form, that Y-intercept, remember when we graph, that's where we want to begin. And it's also the only point that we know for certain is on the line. So there are several different ways that we've got to know how to write equations. Several different sources for the information, but the end result is still going to be a y equals mx plus b equation. So however we get m, however we get b, wherever they come from, you'll see several of those examples. And then we're going to look at parallel and perpendicular and how that fits in with all this, because it's related. So in your materials for this section, and I apologize I didn't get these out sooner. They are available now. Several different sheets that start off this way. Introduction to new material. It says we can write the equation of a line given the slope and the y-intercept. I wonder why this one's showing up the way that it is. This one. So I'm going to start off and go through these from the easiest to the ones that require a little bit more work. So if we're talking about like this first focus question, it says write the slope-intercept form of the equation of each line given the slope and the y-intercept. Well, there's no calculating. It's a simple substitution. So we get the slope as 4/5, put it in where m goes. The y-intercept of -1, put that in where the b goes. And what you'll see, once you start doing that, not -b, -1, sorry. So 4/5 will go here in the first blank because that's where m naturally goes. In this final form, we don't need this plus sign in front of the -1, right? Because the minus sign that came into the equation with the with 1 is part of the term. Because that y-intercept, that means we're crossing the y-axis at -1 on y. Right, so our answer is going to be simply y equals 4/5 x minus 1. There's our slope-intercept equation. This is the easiest one of all of these. Everybody see how I got that? The second page of this particular handout is designed for two people to work together on, but they're all the same. You've got the slope given to you. You've got the y-intercept. Slope is always m. The y-intercept is always b. So this is kind of just a plug and chug exercise where you just get used to rewriting slope-intercept equation. So what would that first example, what would our equation be?
Y equal negative x plus 4.
Got two different correct answers. One in class and one out there. Good, thank you. In class, I heard -1x, which is technically correct, but not really necessary. We don't need the 1 there anymore because we just have the single x. But just got to remember, if all you see is one letter, then you know that the coefficient for that letter is 1. In this case, it's -1. What about the second example here with the slope of 1 and a y-intercept of 0?
Y equal,
Y equal 0. X.
How about y equals x?
Yeah.
Remember the other day we were looking at some examples where the y-intercept went right through the center of the graph at 0, 0. So you'll never see an equation that says +0. But if there's nothing there, nothing shown in that position where you normally see the letter B or the value for B, you know that it's going through 0 for that exact reason. It's not going to show up. Nobody's going to write that into the equation. It's not necessary. And again, our coefficient of 1, we don't need it. It's understood with a single letter, the coefficient, the modifying value for that number is going to be 1. It's a positive 1, so we don't have to put even a sign in front of it. So I wanted to point that one out because that's the only really unusual one in this group, but this would be a good thing to practice on. If you're not sure about how to format these or how to write them, practice on these, send me a picture and I can give you the feedback because there's nothing else to it. Plug in the m, plug in the value where m is, and then plug in the value for b. Questions, anybody? If it's a 1 or a 0, what?
It just stays 1.
No, not if it's a 1.
Well, no, for the slope, you don't have to put the 1 there.
For the slope, Well, anytime you have a variable, it's just a single letter, you're not going to show a 1. If it's a 0, you won't even see the letter. Because this multiplication, remember, that is 1 times x.
Right. So
If you put a 0 in there, it's 0 times x, and then it disappears completely. 0 times x is 0. We don't have a slope of 0 here. A slope of 0 is a line that is horizontal, right? It's flat. So our line would be y equals 3 or y equals -4.
So on graphing that, how would you graph that then?
This one, y equals x.
Yeah.
Any number that you put in for x, y value is going to be the same. Y equals x, right? So you'd have the point 1, 1, 2, 2, -3, -3, 0, 0. Doesn't matter what you choose for x, y is going to be the same. It's basically a diagonal line that goes right through the center of the graph. You know, a slope of 1 gives you that nice, you know, 1 box at a time stair step look. Up 1, over 1, up 1, over 1. So the second variety here is this one. Slope from a graph. This is the second easiest. Anybody want to guess why I say that's the second easiest? Because we can see the graph. What's the y-intercept on this first graph? 1. Yeah, it's 1. It's crossing the y-axis at a +1, +1. So that's what we would plug in for B. If you notice down here in step 2, there's a spot that says identify the y-intercept, which would be 0, 1. 0 because we've not gone left or right at all from the origin. We're sitting right on the y-axis. Now, step 1, you guys can do that if you want. This is what everybody was trying to guess earlier about finding the slope, y2 minus y1 over x2 minus x1. I'm not going to do that. I would encourage you all not to do that also, because that's too much work. Because what this step here is suggesting, again, you can do it if you want, is finding 2 points that are on this line and doing that calculation to find the slope. Well, I got a graph. How can we find the slope from a graph? We can start at a point, go up and over to another point on the line. This is a slope of -1. I don't need to do any calculation for that. I can see it. I'm just counting boxes. I'm drawing a line from 1 here on the x-axis, up 1, over 1, left to 1 on the y-axis. That's a slope of 1. And it's going up and to the left. So I know that it's going to be a negative slope. So my equation here would be y equals -x plus 1. If you wanted to do the calculations, it wouldn't matter which 2 points you picked on the line. You could go down here to 4, -3, all the way up here to -4, 5, do the calculations. You're still going to get the same answer. It's just so much easier when you can see it and use the graph. So again, I'm not going to write the 1, I'm just going to put the minus sign in there. And because it's crossing at the y-axis at +1, there's nothing more to that one. I would much rather have the graph whenever I can. And what happened to the graphs here? There we go. Same thing here on this second example. It says choose 2 points on the graph. Use these 2 points to solve for the slope. Okay, we can try that. This one right here? What? I heard some numbers, but I'm not sure what you mean. -2, comma 1? This arrow right here, see my arrow?
Yeah.
That's left 2,
That's the negative.
up 1.
And then the bottom is that negative 3.
Wait a minute, let's talk about 1 point at a time. You said -2, so I went left 2. Then where am I going to find the second value of the ordered pair? Remember, 2 numbers, 1 point. Okay, up to 1. Right there. It's crossing the line at +1 on the graph, right? Left 2, up 1. That's -2, comma 1. Well, where's another point on the graph? -3 is over here. Not on the line. X is first. X is first. How about 0, -3? Because isn't that the Y-intercept?
Yeah.
Why not use the point? You're going to need it anyway. They're giving it to you with the graph. This is my whole point about seeing and working with these graphs. Take what they're giving you. The Y-intercept is -3. I know that already because I can see it right there. 0, left and right, down 3. That's 0, -3. So if we're going to do the calculations, this becomes -3 minus 1 over 0 minus 2. Okay, so that's -4 over 2. Which equals -2. Now that's a lot of extra work to come up with something that I could have seen right here on the graph. See if I can make that bigger. What's it doing? See this point right here? I'm going to go to the right and down, and I'm hitting the line again. I went right 1, down 2. There's my -2. If I go the other direction from that same point, up 2, left 1, it's still -2. Again, if you got the graph, let the graph do the work for you. Don't worry about doing all these calculations. It can do that as many times as I want. Down 2 over 1, I'm on the line again. Down 2 over 1, I'm on the line. Down 2 over 1, or start at the bottom. Up 2, left 1, up 2, left 1. That's what the slope means. Remember, it's got to be a consistent change, consistent rise over consistent run. Up and over. Up's positive, down's negative, left's negative, right's positive. The combination of those signs is going to tell you what your slope is in the end. And because I can see the line on the graph, I know automatically that this is a negative slope line. It's going up and to the left. I don't really care about any of this below the x-axis. That line is going up and out of the graph in that upper left-hand corner. That's quadrant 2. Remember the quadrants? Quadrant 2 has mixed signs, positive, negative. Even if you look at this part down here, quadrant 1, 2, 3, 4, that has mixed signs also. So it's going to be negative. Because rise and run is a fraction, when the signs are different, just like when we're doing division. When the signs are different, you get a negative number. So the equation for this one, y is negative 2x minus 3, and I'm going to take that plus sign out of there because it doesn't mean anything. Plus minus means you still have a negative number. So that's the second easiest. Anybody have questions about how I did any of that? All right, now comes the third variety. Slope-intercept. We can write the equation when the line is going through a given point with the given slope. Okay, so we don't have a graph. We know we have a point because we have the XY coordinates, and we're told what the slope is. So we don't have to calculate the slope. If you look at focus question number 1, this particular sheet's got a really good definition of the Y-intercept in it. The point where the line touches the Y-axis, the Y-intercept is the point 0, B. So if you have trouble remembering where that goes in the equation, just remember 0, B. When x is 0, y equals b. So that gives you your Y-intercept. The nice thing about this situation is we're going to use the form of slope-intercept to help us come up with the actual equation. Because we have everything except for b that we can substitute in to the form to find what b is. We've got the slope. Slope's -4. Put it in the second step also. This first blank here, that's where the y goes, right? This is y equals mx plus b. Y equals mx plus b. So what's the y value? It says replace the x and the y in the equation with your ordered pair. Where'd you get 1? What's the ordered pair that they're talking about here in focus question number 1? 0, 4. There's no 1 in that particular ordered pair. What we need now are to put the x and the y in the correct location in this equation. So what is the y value that goes at the beginning of this equation that we're trying to work out? 4. That's the y value in the point. And the 0 goes where the x goes in the equation. So now we only have a 1 variable equation we can solve for b. That's all we're missing, right? We need b. We already have the slope. So simple equation solving means I got to add 4 to both sides. It's probably not going to line up correctly the way this is formatted. So simple equation solving using those opposites. So what is b now? Why would I add 4? I didn't do that on purpose, but I really messed up. No, it's even dumber than that. I'm sorry.
Because -4 and a +4 is ordered pairs.
No.
Zero pairs.
Hold on. You're going to laugh at me. And I think I heard Kapana or somebody say -4 times 0 is 0. It's not 4. I'm not adding 4. I'm not adding squat. Because it's just 4. I didn't do that on purpose either, but that's the kind of silly mistake that can happen. I don't need to add anything to this because -4 times 0 is 0. I just got thinking, well, that's just a -4 there all by itself. Well, it's not. It's -4 times 0. And then I started looking at that and I'm like, wait a minute, I'm going to get 8 for B. And I know that's not right. How do I know that 8 cannot be the correct answer? Let's go back to this definition of the Y-intercept here. Look at, Look at the definition here. I'm highlighting it in yellow. It says the Y-intercept is the point 0, comma B. Look at the point that they gave us. 0, comma 4.
You're always going to have the point on 0 and then up 4/4 down 4/4, right?
No. The Y-intercept is only on the Y-axis. Remember, the first value is what you do left or right. That's the X value. It says 0. I'm not moving at all left or right. I'm still sitting at 0, 0. The second value is what you do up and down. The Y-intercept has to be on the Y-axis. And the definition right here says the Y-intercept is the point 0, comma B. Look at the point they gave us, 0, comma 4. That is the Y-intercept.
So would it be 0 and then up 4?
Yes. So that's why I started scratching my head thinking, oh, I did something wrong here. There's no way that that is 8. It can't be 8 because I know by the definition that 0, comma 4 is the Y-intercept. They gave you the Y-intercept without telling us that it is. And at first I didn't recognize that because I wanted to do a silly calculation that I didn't need to do. So anytime you see that structure, when the X value is 0, you're getting the Y-intercept. That's why I tried to emphasize that definition and didn't do a very good job of it, obviously, because I didn't remember it. I failed miserably. So ashamed. So now I got an equation, y equals -4x plus 4. Okay. Now I'm going to pause this for a minute and give you guys a chance to do the next one. Using that slope-intercept equation with this point, -4, comma 3, and a slope of -1/4. All right, we have a winner. We got the Y-intercept of 2 because we put the slope here where M goes. We took the point values, the X and the Y. The Y value is 3. Slope is -1/4. Whether you recognize it or not, -1/4 and -4 are reciprocals of one another. So that gives you a +1. -1/4 of 4 is 1. They're both negatives. So negative times a negative gives you a positive. So you're going to end up subtracting 1 from both sides. Now we have an equation of y equals -1/4 x plus 2. This process will work for you every time you need to find or write a slope-intercept equation. Now, the other thing about this particular setup here with 1 point and the slope, did anybody think about using point slope form? Because point slope form is tailor-made for this. Just like the name says, it's designed to be used when you have 1 point and you have the slope. So since I mentioned it, I'm going to show you what I'm talking about. Point slope, even though it's not my favorite, is valuable in some situations. So remember, point slope is y minus y1 equals m times x minus x1. The x1 and the y1 are coming from the point. Our point is negative 4 comma 3. M is negative 1/4. Okay, now you just start plugging stuff in. Y value goes here, M goes here, X goes here. Y minus 3 equals negative 1/4 times X minus 4. Got the minus in there because the sign on the 4 is a minus sign. The equation has a minus sign right in front of that position. So I got to use both of them. So y minus 3. Now I got to do distributive property. This becomes keep, change. I get negative 1/4 X, negative 1/4 times 4 is negative 1. But once I solve point slope equations for y, I get slope intercept. Negative 1/4 x plus 2. Exactly the same. A little bit more work, more signs to keep track of. It's part of the reason why I'm not a big fan of point slope. Some people really like it though, so it's okay to use that. Same exact result. Negative 1/4 x plus 2. Question, anybody? Okay, one more example on this one. Same thing here. I'm going to pause it, give you guys a chance to work out this one. All right, good job, you guys. And especially for anybody that's trying to do this in point slope, it's not easy. Keeping everything in the right order, the right position. Yeah, good, Rebecca. Questions, anybody? All right, now the fourth way to identify and write equations. I think this is the right one. Yeah, here we go. This one is the most work. But you also have some choices that you can make while you're working on it. Give you the same definition here for Y-intercept. I don't know why this here is not showing up, but it's supposed to be the slope equation. Maybe it's not big enough. Oh, I don't know. Sometimes Word documents don't translate into Google Docs the way they should. So I need to fix that, and I will. So here you see our first focus question. It says write the equation of the line passing through the points -4, -5, and -3, 2. Oh, I don't know what the slope is. I don't know what the y-intercept is. So now we got to find both. This is where that slope formula comes in. So -4, -5, -3, 2. I'm gonna go ahead and do the whiteboard on this one. And slope formula, remember, is y2 minus y1. So the change in y over the change in x. That rise is on the top, the run is on the bottom. So this is up and down. X's are left and right. So -4, -5. I'm going to call this one point number 1. So when I was first starting to do these things, I always labeled them x1, y1. All that means is that those are the values for my first point, for x and y from the first point. Second point is -3, 2. This is x2, y2, x and y from the second point. Now, when I do this equation, I'm filling in these boxes with those values, with their signs, and I'm keeping the minus sign in between. I don't eliminate any signs until I'm sure I've got all the terms in with their signs. If you do, you're going to get the wrong value, the wrong positive or negative value in the end. So y2 is 2, y1 is -5, x2 is -3, x1 is -4. This is a good example on both of these why you need to keep all these signs in here, because now this top part becomes keep, change, change. So I get 7. And on the bottom, you might be tempted to get 7 here also, but you would have done it wrong because this becomes -3 plus 4. So it's not going to be 7 over 7. It's 7 over 1, which equals 7. So now you have a choice. You can do point slope with either one of these points, or you can keep doing the y equals mx plus b mixture. And you get to choose which point you want to use. It does not matter whatsoever. The thing is, because you know both of these points are on the same line, it's automatic that you're going to get the same slope-intercept equation regardless of which point you use to figure out what b is. If you didn't, then they're not on the same line. And they're telling you in the problem that this line goes through these 2 points. So that has to be subject to the same slope-intercept equation. So I'm just going to choose the second one because it has lower numbers and only one negative. Makes no difference. Y equals mx plus b. See the substitutions that way to find b. 2 is our y value. M I just figured out is 7. X is -3. Wow, this is going to be a big number. Plus b. Okay, so 2, this equals -21. Add 21 to both sides. This is a very steep line. Remember, our high numbers, our high whole numbers give us very steep lines, and with a y-intercept of positive 23, that's, you need a big graph to be able to even show that. So I know what B is now. I already figured out what M is. So my final equation would be y equals 7x plus 23. Now, you guys out there that are keeping me honest on my signs, did I miss anything? I hope not, but I want you to keep doing that. Now, when I say I get the same value, the same y-intercept, if I use the other number, does everyone believe me? Or should I show you? You don't have to believe me. I'll do it anyway. -5 equals 7 times -4 plus B. -5. I'm having a hard time writing with this today. Equals -28 plus B. Now I'm going to add 28. And I still get 23 equals B. Sometimes, well, especially like if you have a fractional slope, there's might be an advantage to choosing one of the ordered pairs over another, but it's totally your call.
So we always get the same, when we have two coordinates like that.
If they're on the same line, has to be. Otherwise, they're not on the same line. And we're only talking about one line here. All right, so should be another example on here for you guys to do. And yeah, I think there's only this one. So we'll do the same as we did before. I'll pause this thing so you guys can work on it. I don't know, which point did you use, Kathy, to get that? Did you use the first one or the second one?
I used
3,5? Okay.
yeah,
I used the other one just because both numbers were 1. I already had an equation. I had a number 1 out of my result from the slope. I figured that's going to make my calculations easier. How can I mess up number 1 times whatever? And I got the same thing that you did. So we would have ended up with 1 as our y value, or 5. Let's do 5 because that's what you said. 5 equals 1 times 3 plus B. Now we're going to subtract 3 from both sides. All right, minus 3. And minus 3 to cancel the 3 on the right. There's your 2 equals B. So y equals x plus 2. And again, we don't need to put the 1 in front of the x. The slope is 1 or -1. We won't bother writing the 1 in there. It's not necessary. It's understood. So in a nutshell, even if you take point slope out of it, those are 4 ways to write equations. The one thing that we have not done out of any of this today is to write equations from standard form to slope-intercept. But that's the same basic process as if you did point slope when you're going to solve for y. Questions, anybody? Okay, and all four of these documents I pulled right out of the materials that have been posted for this this particular week. In that same grouping is this slideshow. Nope, don't want that. The slideshow, if you want more practice, go to this slideshow. This particular thing is set up to be like a game. So if you go to any of these slides here, right there, that first example, find the slope-intercept form of the equation, 4x minus 8y equals 10. Would you know what to do? This is what I was just talking about. We're going to take standard form. That's in standard form. ax plus by equals c. And we're going to solve it for y. So don't forget the conversion process when we're going from standard form to slope-intercept. 4x minus 8y equals 10. Solving for y means all the other terms on that left side got to go to the other side or be eliminated somehow. Just keep using those opposites. I'm going to subtract 4x because that cancels that 4x on the left. It leaves me with negative 8y. And I'm going to put the 4x right after the equal sign because that's where the mx goes in slope-intercept. Negative 8y now equals negative 4x plus 10. One last step. Divide everything by that coefficient of y. Negative 8, negative 8. Y equals 1/2 x minus 4/5. Where the heck did I get those numbers? You really want to know? Well, I did it on purpose. I'm dividing here, right? So my negative 8s will cancel. This here is negative 4 over negative 8. What do I always say about fractions? Reduce, reduce, reduce. Both of those are divisible by 4. Again, another, right, there's the 1/2. This is another good example of why I preach about knowing your multiplication tables, because when I see numbers like 4 and 8, I pretty much automatically jump to, okay, I know they're even, so they're divisible by 2 for sure. But then I take another step up, not 3, but 4 definitely. And then the other one, 10 over negative 8 is similar, only I can't quite reduce it as much. Hey, and I got it upside down. So that should have been 5 over 4. You gotta speak up.
I was trying to figure it out if I was wrong or you were wrong.
No, I think there's a pretty good chance that I'm going to be wrong, because I get to talking and doing something else and I'm thinking about the next step and I don't finish what I'm doing. What a surprise. Negative 5 over 4 should have been what I came up with, because those are both two even numbers. They can't reduce any further than that. So anytime you see fractions, you want to try to reduce them whenever possible. So yeah, tons of other problems in this slideshow like that. So we don't have time to go through all of them by any means today. But here's an example of the first kind that we did. You got the slope, you got the y-intercept, write the equation. Here's one where you've got one point and the slope, so you could use point slope, or you could then find b doing the y equals mx plus b with substitution. How many are in here altogether? I swore I saw one with 2 points. Yeah, here we go. Here's another example. It's got 2 points in it. Same kind of thing we've just been doing. So it's repeated practice over the techniques of those 4 different things that we just were doing. Questions, anybody? All right, the last thing for today says graphing parallel and perpendicular lines. We got some rules. We're going to add to your list of rules already. We're going to end up being able to write the equation of a line if we have a point on the line and the equation of a parallel line. So now we're starting to talk about 2 different lines. You got to visualize, okay, we got an equation for one line and we're going to come up with an equation for the second line that's parallel. So that's the first objective. The second one is kind of the same thing, but only now we're talking about a second line that's perpendicular. Remember what perpendicular means? Crossing at a 90-degree angle. Just like the bricks on the wall here, or the grid and the tile in the ceiling, where the floor meets the wall, 90-degree angles. Perpendicular. So here's a graph that's got a couple of parallel lines on it, showing you the equations. Anybody notice anything that stands out about either the equations or the lines? Okay.
And they're not on.
Okay, we're talking about parallel or perpendicular here, so keep that in mind. Look at the equations. What do you notice about those 2 equations? The what's half? X is not half. What is it that's in that position where 1/2 is? Slope. The slope is 1/2. M is 1/2 on both of them. That's the rule for parallel lines. Slope is the same. So if we're talking about a second line, the only thing that's going to be different is the y-intercept. So they might give us an equation for one line and say we've got a parallel line. So we're just going to, if we need to write a second equation, we're just going to borrow the slope from the first one. Because automatically by rule, I know that the slopes are going to be the same. And the way these are graphed, you can see they're never going to cross. You got one with a y-intercept up here at +4. The other y-intercept is down here at -2. I'm going up 1 over 2, up 1 over 2 on both of these, up 1 over 2. So that's the first rule. Parallel lines have the same slope. Always, always, always. Now compare that one to this drawing and these equations. Look at the numbers that are in red. Yeah, they intersect at a 90-degree angle. But look at the numbers though that are in red. Okay. Do you recognize those as reciprocals? 4/1 is the reciprocal of 1/4. Remember, the reciprocal just means we take a number and we flip it over. So this is the second rule with perpendicular. Only applies to perpendicular. We have what they call negative reciprocals. The y-intercepts are going to be different for sure. And the slopes are going to be different in a specific way with this negative reciprocal relationship. If you're not sure about the reciprocal and one of these is a whole number, put it over 1. Make it look like a fraction. So when you flip it over, you'll see what the reciprocal actually is. Here's what I'm talking about with these in this second line here, circle the pairs of numbers that are reciprocals. 7 and 1/7 are reciprocals. Forget about the signs for a minute. Just think about the flipped over version of one or the other.
0 and 0 and 12.
Those are not reciprocals though. It's just the same thing. 3/4, -3/4 and -4/3. That's the other reciprocal on that line. The other thing that you may start to see is this under using the symbols. In the red here, you see this AB with a double-headed arrow over the top of it, and then 2 vertical lines next to it, and then CD in blue with a double-headed arrow over the top of it. That double line in the middle is not 11, it's not 2 L's. It's the math symbol for parallel. So this would read as line AB is parallel to line CD. That symbol there comes straight out of geometry. Perpendicular just means we're going to have 2 lines that intersect and create right angles, 90-degree angles. If you're building a house, 90-degree angles are a good thing. You want your house to be square. Lots of examples of parallel and perpendicular all around us. Every one of these has both. Depends on what you're looking at. Like the railroad tracks, the tracks themselves are parallel. The railroad ties are parallel to each other, but the ties are perpendicular to the tracks. Same thing here with these window panes. Parallel up and down, parallel at the top and the bottom, perpendicular across the middle. So here's a quick example. We're about out of time. A quick example of one of these situations where we're trying to make an equation for a second line. And how do I know it's a second line? Because it's this part right here. It says it's through 2, -5. So that's one line that's going through that point. Whatever that line, however it's described, it's parallel to this other line that I have the equation for. So to the left here, determining the slope just means I'm borrowing it. I'm going to borrow it straight out of the other equation. Because the lines are parallel, they're going to have the same slope. After that, it's exactly like what we were just doing with all these other examples. Using y = mx + b, doing the substitution. Take the y value here, take the slope, the m value, take the x value, calculate what b is. And you're going to end up with a second value for b that's for that second line. So the only twist from what we were just doing is these 2 rules now that we have to add on there. Parallel, let's just borrow the slope. We don't have to calculate it. We can steal it out of the other equation. Perpendicular, I thought I had one of these done. Perpendicular means we got to take this slope here out of this equation, -1/3, and make a negative reciprocal to use to calculate the other one, to come up with the other equation.
So is that gonna make it positive, or do we want it negative? We want it positive.
It's already negative, so when we apply another negative to it,
It'll be positive.
right, it's just like keep, change, change. The negative part of it, if you think about it as opposite sign and reciprocal, that might be another way to keep it clear. Because if it's negative, it's going to become positive when you flip it over to the reciprocal. If it's positive, then it's going to become negative. It's always going to be the opposite sign for perpendicular. So our reciprocal slope would be 3, and the opposite sign for this one would be positive. So then we would start using 3 for m and go through the rest of that calculation. And that is all the time that we have. So 2 new rules there to add to everything else that we've been thinking about. But all that today was strictly about writing equations. There's also a handout in that section on parallel and perpendicular that if you wanted to work on some of these, again, more practice. If we had more time, it could do more of these. Writing different equations from different sources. And under the previous one for slope-intercept equations, there is a handout for graphing and writing equations with all the different varieties. So there's graphing practice in here. You get into 9 and 10, you start seeing some graphs. So now you can write an equation. Find the slope from the graph. Find the slope from 2 points. Slope-intercept equation from different formats. All the different varieties of things that you've seen in terms of equations or graphs and slope are in that other handout. So questions, anybody? All right. Appreciate everybody being here and for your contributions today. We'll see everybody on Thursday.